This long tube shape may not look like a spacecraft to most people, but something like it may someday take instruments to Mars or return cargo to Earth. Packed into its restraining bag is IRVE-3, the Inflatable Reentry Vehicle Experiment, developed at NASA's Langley Research Center in Hampton, Virginia. It's designed to demonstrate that inflatable spacecraft are feasible.
It's very challenging to develop an inflatable spacecraft because you have to use materials that do not mind being packed down into a small volume for launch and then unfolded up to their full size. So we use fabrics, whereas a traditional rigid heat shield would be more of a solid material that doesn't fold.
IRVE-3 is scheduled to launch from a sounding rocket at Wallops Flight Facility, also in Virginia, much like its predecessor IRVE-2 did in 2009. But first, the hardware and software has had to go through a series of tests, including a visit to the shaker table. One of the last destinations before flight, NASA Langley's Transonic Dynamics Tunnel, or TDT, to check out the whole system, inflation and all.
We were using the TDT for a vacuum chamber, and what we do is actually bring it down to low pressure, just like it'll see during reentry, to make sure that this thing's going to inflate properly. During the test, we had the pyro initiators, which are little cutters that they don't explode or anything, they just cut the strings. They initiated, the bag started to unzip, it actually paused, so we all got excited for a minute, and then it just paused a second and let go, and the rest of the bag opened up, the inflatable came out.
That was much to the relief of the engineers, who thoroughly checked the IRVE-3 afterwards. Also performing well during the test, the thermal blanket, which will protect the inflatable from the forces and heat of atmospheric entry. Now the team can only hope everything works just as flawlessly later this year, in space.